All right, here comes part two. So if you recall, we were working with solving trig equations. We will go from 0 to 360 for solutions, and then we will try 0 to 720, see if we can find some more. And then we will try to find all the solutions and find a nice convenient way to write that for our readers. So this next problem, we will need the inverse sine of radical 2 over 2. So you should be thinking about your nice unit circle. Here is a nice 45, 45, 90 right triangle, and that should be my first solution. But I do understand that since all students take calculus, there would be another 45-degree angle in the second quadrant. We would call it 135, and that would also be a good solution. Now, as I go around the unit circle, though, I will not find another solution for myself until I get back into quadrant 1. So I need to take that 45 and add 360 to it to get another solution. So that would take me to 405. If I do the same thing for my quadrant 2 angle, I'd have to go another 360 past 135. So that's going to take me to 495, and so on. So we have a little bit of a complication on our final answer here. So we would write something like 45 degrees plus integer multiples of the period. But we also have to tell the reader you can get more solutions if you go to 135 and add integer multiples of the period. Otherwise, you can't keep going from 45 to 135 by adding 90 degrees. And then how do you go from 135 to get back into quadrant 1? It's a completely different rule or pattern. So you want to establish two different patterns for your reader. Okay, we need inverse cosine of negative radical 2 over 2. So I hope you are thinking about quadrant 2, which is where you will have your first negative cosine answers. So we know that's going to be 135. Now, that triangle shares the same adjacent side with the one down here in quadrant 3. So that angle would be 225. Now, we're in sort of the same situation that we were up here. From 135, I have to go full circle to come back to quadrant 2 again, while from 225, I have to go full circle to come back to quadrant 3. I can't go from quadrant 2 to quadrant 3 by one rule and then try to come up with some other strange rule to get back to this quadrant. So I'm going to list 135, 225, and then I want to add 360 again to get a new angle called 495. And I want to add 360 to this one and get 585. We're going to set up this same type of description. So 135 plus integer multiples of the period, but also 225 plus integer multiples of the period. Maybe you're starting to get the swing of this. All right, this is a tricky one. We know that we're going to have to take the square root first. And we do have to think about the plus or minus sign. So, boy, now we can think about all four quadrants where we're going to have both positive and negative radical 3 over 2's. So think about the positive 3 radical 2's. which angles would those be? And then those negative radical 3 over 2's will be those same reference angles. So if this first angle here is 60, what is the next angle over here? Take a guess. And one last time. Boy, that's a lot of solutions between 0 and 360. So we're going to list those answers plus some more. So you want to go 60 past 360, so 420. You can just keep adding 360s. 480, add 360 to that. 600, add 360. Whoops. So do you see a little pattern there? Well, how do I go from 60 to 120? Do I do the same thing to go from 120 to 240? No. Do I do the same thing to go from 240 to 300? Well, this pattern adds 60, but this pattern does not. So when we go to write this explanation for our reader, we can't use that. We can't change the rule of how you get from one solution to the next. So let's see if we can outsmart this. Well, and I'm also trying to show you here, look at what the period is. The period is 180 degrees. So if I add 180 degrees, do I get to 240? Yep. If I add 180 degrees to 120, do I get to 300? Yep. And so on. So I guess I'm going to make two listings for my reader. I'm going to say 60 degrees plus multiples of 180, which is the period, but I also have to separately list 120 plus n times 180. That's some tough stuff. You're going to have to work hard on this section. End of video 2.